In this segment, we will be looking at the graphs of exponential equations, the basic type or problem type 1. And here we have g of x, or y is equal to negative 2 to the x. So let's go over here and take a look at our notes. In fact, I'll do a couple variations of this problem here for you, and then we'll talk about a couple of others. First of all, let's notice here that it might be easier for us if we were to simply take a look at the function y equals 2 to the x first. And so then we'll look at the other ones here. Usually what I'll do here is talk about basic types, and then we'll look at the other ones that come up as transformations of those types. And we've had that teaching earlier. So let's go through here first time and just kind of plug and chug like we basically learned in Algebra 1. We'll take negative 2 as our x value. Well, that would be 2 to the negative second power. So 2 to the negative second, that would be the reciprocal of 2 to the second. 2 to the second is 4, so 1/4. Likewise, 2 to the negative first would be 1/2. And here is a key point every time. Notice that 2 to the 0 is 1. In fact, anything to this 0 power is 1. So one of the key points on all of these graphs is going to be the point 0, 1. That point 0, 1 is going to be on every one of these exponential graphs. 1, of course, that's going to be 2 to the first power is 2, and then when x is 2, 2 to the second power is 4. So basically, all of these exponential functions, when you have a base here that is greater than 1, what's going to happen is that the graph's going to look like that. Okay, it's basically going to look like that. Over here on the left hand side, it's going to approach the negative x-axis as an asymptote, because you can see here that these values are coming down. If we were to plot a few more of these, at negative 3 we would have 1/8, at negative 4 1/16, and getting closer and closer and closer here to the x-axis on the negative side. And then over on the right hand side, it shoots up for the sky very rapidly here, because you can see here it's 1, then 2, then 4, then 8, then 16, and so this is going to gain height very, very rapidly. In fact, almost all of these graphs look the same way. The only thing that can be much different is the base, and what happens there is that if the base is bigger, the graph will be a little lower down in this region. It'll go right through that same point and then shoot up faster. So if it was 3 to the x, 4 to the x, 10 to the x, the graphs would all look basically the same anyway. So knowing some of these shapes and being able to transform them is basically a good thing. Now, the problem that ALEKS has asked us here, let's look at this one, is negative 2 to the x. Well, what I can do there is I'll instantly know what that graph is going to look like, because I've been through the transformations. So let's go over here quickly and review the sheet of transformations. This sheet is available to you in your notes section. You can print this out. And basically what we say here is all of these exponential graphs look a lot like this one. Here's the e to the x graph. Of course, e is the exponential number that's 2.718, so it's somewhere between 2 to the x and 3 to the x as far as the way the graph goes, but it has the shape of all the rest of those. Here's some other graphs that we may have talked about earlier. Notice that all the transformations apply. The slides are translations, they're reflections, but particularly call your attention to this one here, because if you have the negative of f of x, what that's going to do is to reflect the graph across the x-axis. So that's really all that's going to happen here. As we try to graph negative 2 to the x, we're simply going to pick up our graph here. We can think about this as being on this piece of plastic, which is a real convenient way to think about that. There's our basic graph of y equals 2 to the x. We're simply going to flip that over, because this negative is going to cause us to reflect this in the x-axis. So right away, our graph's going to do this. Okay, graph's going to do this. So we're going to have this point here, which is 0, negative 1. ALEKS wants us to go ahead and plot out a few of these points on these basic types. So let's go ahead and play along with them and do that. We can see here that if x is negative 2, then we're going to have the value of negative 1/4. So we'll probably have to go ahead and enter the points this way. So we'll have the very same numbers we had before, except they'll all be negative. So we're going to have negative 1/4. And let's plot that. And of course we're going to have negative 1, negative a half. So negative 1 and negative 1/2. So we'll have to plot these points one by one. Of course we can plot this one right there. And of course when we go over 1, it's going to be 2, because 2 to the first power is 2, and of course the negative of that's negative 2, then over 2 and down 4, because 2 squared is 4. So we can plot the 5 points they asked. Then we'll just simply click our graphing utility here. They wanted an extra point here. Okay, I thought we plotted 5 points. Let's try it. And we need to put in the asymptote here. They want that, so let's undo that. Let's get our asymptote line in here, and now we should be able to graph it. And there we go. Basic graphing of an exponential function. Let's do another one of these. Okay, now we're going to have this basic problem here now. We're going to go back and have a negative x here. Well, notice that our base is 3/2 or 1.5. So the graph's going, this base here is at least greater than 1, but we have this negative x. So let's go over here and take a look once again at our transformation sheet. And what we're looking at here is going to be the f of negative x. What that's going to do here is to reflect our graph across the y-axis. So what we're going to do here is basically simply pick up our piece of plastic and we're going to flip it over this way. So the graph that we're going to make looks about like that. Okay, so we know about what it's going to look like. In fact, here, I forgot this last time. Let's go back quickly here and get in this asymptote, which we know is here. We know for sure that it's going to go through this point, because it always does, the point 0, 1. Now, they want us to go ahead and plot these points, so we can take our negative 2, and we can deal with that. So we're going to plug our negative 2 in there. That's the negative of a negative 2, which is a positive 2, which is going to be 3/2 squared, which is going to be 9/4. And so we can go negative 2, and of course we're going to have a positive answer. We know that is the case. So we're going to go over here, click our fraction 9/4. Okay, our common sense is telling us that our basic graph shape is going to look like this, so just kind of keep watching for that to happen. Common sense should kind of govern things here. Let's go back here and take the next point. Now, of course, if we have negative 1, that's going to be the negative of a negative 1, which is positive 1, so it'll be 3/2 to the first power, which is 3/2. So that's going to be negative 1 and 3/2. So we can do that, and we'll plot that point. Okay, going out in this direction, then we'll have 1. Well, if you have 1 in here, that's the negative of 1. 3/2 to the negative 1 power, that's the reciprocal, and so that'll be 2/3. So we will have the point 1, and here we will have 2/3, because that's the reciprocal of 3/2. And the graph, once again, is looking right here. We can see that that's kind of what it's supposed to look like here, because it's supposed to come on down, approach this positive x-axis as an asymptote. One more point, so we're going to put in the 2, so that's going to be 3/2 to the negative 2. But remember, that's going to be 2/3 to the positive 2, which is going to be 4/9. So we're going to plug in 2 and then the fraction 4/9. And we'll plot that. Once again, that's looking good here. Got our asymptote in this time. Didn't forget that. And so let's graph and make sure that ALEKS is indeed happy. And that's about how these will go. This is the basic of the exponential graphing in ALEKS College Algebra.